everyone, today we're going to be talking about graphing transformations of the quadratic parent function. I know that this is quadratic because there's this little squared superscript here. So it's going to be a U-shaped graph, which is called a parabola. I also know that this is written in vertex form because it would be very easy to identify the vertex based on the transformations that we see. Okay, the left, right, and up, down shifts will tell us what the vertex is. Okay, let's just move through a quick review. I'm going to start with the stuff that's outside of the parentheses. Anytime we're looking at the components outside of the parentheses, that is going to be vertical change, which is going to affect our y values. So if I have got a negative sign in front of A, that's a vertical reflection in the x-axis. So we're going to be multiplying our y values by -1. If we are looking at A, that is a vertical stretch if A is bigger than 1, and a vertical shrink if it's less than 1 but bigger than 0. Again, it's outside parentheses, so it's vertical, which means we're going to multiply y values. Remember, your vertical axis is your y-axis. Okay, and then back here, again, we're outside parentheses. That is vertical movement up or a vertical translation down. Okay, and in order to move the graph up or down, we're either going to be adding k units to the y value or subtracting k units from the y value. Okay, then we move inside parentheses. This is all horizontal movement, so remember the horizontal axis is your x-axis, so this should all be changing the x value. The negative sign is going to be a horizontal reflection, and we're going to be multiplying the x values by -1. The b value that's inside of here indicates a horizontal stretch or shrink. For that, we're going to multiply, again, it's the x value that changes, by the reciprocal of b. Don't forget, horizontal stuff's weird. You got to use the reciprocal there. X plus or minus h, that's going to be your horizontal translation left or right. You're either going to subtract h from the x value if you're moving it to the left, or you're going to add h to the x value if you're moving the graph to the right. Okay? Just something else to keep in mind when you're doing the transformations, you always want to move from left to right when you're listing the transformations. So start with the reflection out front, the vertical reflection, then do vertical stretch or shrink, then do horizontal reflection, then do horizontal stretch or shrink, then do left, right, then do up, down. You want to make sure that you're moving from left to right when you are constructing your XY transformation chart. The reason is because of the order of operations. Let's take a look. Moving left to right, notice that here you see the word multiply, here you see the word multiply, here's multiply, multiply. Then we get into add, subtract, add, subtract. Okay, order of operations matter, which is why you always want to move from left to right. Because of PEMDAS, we always want to make sure that we're taking care of the multiplication before any addition or subtraction. Okay, so just make sure you're doing it in the correct order. Again, if A is bigger than 1, that's going to indicate a vertical stretch. If A is less than 1 but bigger than 0, that's going to indicate a vertical shrink. If you see a negative sign out front, that's going to be a vertical reflection in the x-axis. Then we move inside the parentheses. If B is bigger than 1, remember this is weird because it's horizontal. That's going to be a horizontal shrink. When B is less than 1 but bigger than 0, that's going to be a horizontal stretch. If you see a negative in front of B, that's going to be a horizontal reflection, which is also known as a reflection in the y-axis. Okay. X plus h and x minus h, again, it's horizontal movement, so it's weird. X plus h is going to be a translation left. h units, and x minus h is going to be a translation right h units. Plus k and minus k, that's your up-down vertical translation. Plus k would be up, minus k would be down. Okay, the shape of your quadratic parent function, x squared, is going to have a U shape. Okay, also known as a parabola. And in order to find the 5 parent points that will transform later, you're just going to pick some negative x values, 0, and some positive x values. And remember, we're squaring all of those inputs. So negative 2 squared would be 4, negative 1 squared is 1, then we'd have 0, 1, and 4. All right. Let's go ahead and take a look at the next part. It says anything outside of the absolute value bars or parentheses indicate what kind of change. Well, here we're talking about quadratic functions, so we're specifically talking about the parentheses. Anything outside of the parentheses would indicate vertical change, right? Vertical, which will affect what values? What is that axis called? What is your vertical axis called? It's called your y-axis. So we affect the y values. Whereas anything inside the absolute value bars, or in this case inside the parentheses, would indicate horizontal change. And that's because your horizontal axis is your x-axis, which will change your x values. Okay, horizontal change, remember, it is weird. X plus h is to the left and x minus h is to the right. For horizontal stretch or shrink, you have to find this reciprocal of b. Okay, the word reciprocal means to flip. So the reciprocal of 2 over 1 would be 1 over 2. The reciprocal of 2/3 would be 3/2. Okay. So in this first example, it says describe the transformation of x squared that's represented by g, then graph each function, show work. Okay, so again, we've got to move from left to right. Number 1, the first thing that I see is this negative sign. That is going to indicate a vertical reflection in the x-axis, or over the x-axis. The next transformation I see is the 1/2. There's no parentheses around it, so again it's vertical. Vertical, that's going to be a shrink by 1/2. I know it's a shrink because it's a number between 0 and 1. All right, let's go ahead and graph the parent function. I'll do that in red. For the parent function, again, we're going to use the same key points that we always do. I'm going to use the key points -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Make sure it's a nice U shape, nice smooth curve. Okay, and then I'm going to transform those parent points. For a vertical reflection, we're going to change the y values. I'm going to multiply them by -1. 4 times -1, 1 times -1, 0 times -1, 1 times -1, and 4 times -1. And then we're going to do our vertical shrink. Again, it's the word vertical, so it changes the y values. I'm going to multiply by 1/2. So I'll get -2. 1 times 1/2 is -1/2. 0 times 1/2 is 0. -1 times 1/2 is -1/2. And -4 times 1/2 is -2. Okay, and then I'm going to graph those new points. I'll do this in black. We have -2, -2. -1, -1/2, 0, 0, 1, -1/2, and 2, -2. All right, because of the vertical reflection, I should have seen the graph flip which I do see, and because of the vertical shrink, my graph should widen or flatten out, and it does look a little bit wider than the original parent function. Okay, if you're not creating a color coordinated key, please label which function is which. So I labeled my parent function, and then this function I'm just going to label G. All right, next one. Again, we're working from left to right. Number 1, the first thing I see is the 2. It's inside parentheses, so I know that it's horizontal. Horizontal blank by the reciprocal would be 1/2. So I'm going to fill that in with shrink. Okay, then we've got this +1. So that is outside of parentheses, so I know that it's vertical. So I'll say it's a vertical translation. That would be up 1. Okay. All right, we're going to start with our parent points. I'll do it again in red. So x, y, we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. We'll go ahead and plot that U shape. Okay, and then we'll transform that graph. We need to do it in the correct order, so I'll start with the horizontal shrink. It's horizontal, so it changes the x values. And I'm going to use that reciprocal 1/2. So I multiply by half. -2 times 1/2 is -1. -1 times half is -1/2. 0 times half is 0. 1 times 1/2 is 1/2. And 2 times 1/2 is 1. Okay, so that's done. And then a vertical translation, up 1. It's vertical, so we're going to change our y values here. We're going to add 1. 4 plus 1 is 5. 1 plus 1 is 2. 0 plus 1 is 1. We get 2 and 5. I'll graph this in black. -1, 5. -1/2, 2. 0, 1. 1/2, 2. And 1, 5. Let's think if this makes sense or not. Horizontal shrink, if I take something and I squish it up horizontally, it should get more narrow. So that makes sense that it got more narrow. And it does look like the vertex, we shifted it up 1 unit. Okay, so that looks good. Again, move left to right. First thing I see is the 2 out front. Because it's outside parentheses, it's going to be vertical. And because it's bigger than 1, it's going to be a vertical stretch. Make sure you're putting the scale factor by 2. Then we come to the x plus 1 on the inside there. It's inside parentheses, so I know that it's horizontal. Opposite of what you think, so it's going to be translation to the right one. Okay, last but not least, we see this -4. It's outside parentheses, so I'm going to say that it's a vertical translation, and in this case it would be down 4. Okay, let's go ahead and write our parent points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, and we're going to transform those parent points. Let me go ahead and zoom in on this. We first have a vertical stretch by 2. It's vertical, so I'm changing all the y values, multiplying all the y values by 2. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. And 4 times 2 is 8. Okay, so that's done. Then we have a horizontal translation, right 1. It's horizontal, so I'm going to change all the x values. I'm going to add 1 to them. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. Okay, so that's done. And then I have a vertical translation, down 4. Okay, it's vertical, so I'm changing the y values. So I'm subtracting 4 from all the y values. 8 minus 4 is 4. 2 minus 4 is negative 2. 0 minus 4 is negative 4. 2 minus 4 is negative 2. And 8 minus 4 is 4. Okay, and that's done. Now look, pay close attention. Do you see here how PEMDAS came into play? I wanted to make sure that I did this multiplication by 2 before I did the subtraction of 4. Okay, so make sure you're maintaining correct order of operations. And I will go ahead and graph that function in black. Okay, so all my function g's are in black in this case. So I have negative 1, 4. 0, negative 2. 1, negative 4. 2, negative 2. And 3, 4. Make it a nice U shape. Okay, and there you go. Based on our transformations, it should look more narrow to the right 1 and down 4, which it does look a little bit more narrow, just because normally I go up 1 over 1, and here I'm going up 2 over 1. So it's a little bit steeper or more narrow. And we did shift the vertex right and down. Okay, go ahead and try these on your own. You can pause and try these on your own. Okay, in these practice problems, it says to describe the transformations, list the 5 ordered pairs you'd use to graph the function g, and identify the vertex of function g. So first things first, listing the transformations. The 1/3 here indicates a horizontal stretch by 3. It's inside parentheses, which is why it's horizontal, and I have to use the reciprocal. Okay, so I'll list my parent points. These are the points that we're going to transform. Okay, I'm using the quadratic parent points. And to horizontally stretch it, I'm going to change the x values and multiply by that reciprocal of 3. So negative 2 times 3 is negative 6. Here you get negative 3, 0, 3, and 2 times 3 is 6. Okay, so those are the 5 ordered pairs that I would use. I would use negative 6. Oops, I almost put negative 4. I would put negative 6, 4, negative 3, 1, 0, 0, 3, 1, and 6, 4. And to identify the vertex, again, I started out with 0, 0, and I ended with 0, 0. Okay, so this is my vertex right here. I can tell it stayed 0, 0 because in this original function, there was no left, right, or up, down shift. So it stayed 0, 0. Okay, in the next part, moving from left to right, the first thing that I see is a vertical stretch by 3. I also see, because it's inside parentheses, it's horizontal, a horizontal translation, right 1. To get my points, I'm going to first write my parent points, and I'm going to transform those to vertically stretch by 3. It's vertical, so I multiply the y values by 3. Then to horizontally translate it, write 1. It's horizontal, so I'm going to add 1 to my x values. Okay, and that gives me my new points. Negative 112, 0, 3, 1, 0, 2, 3, and 3, 12. Okay, and what's my vertex? What's right in the middle here? 1, 0 is going to be my vertex. I could have told you that it was the vertex 1, 0 just because I can see that there's a shift right 1 and then no shift up or down, right? So because I shifted my graph right 1 but didn't shift it up or down at all, that is why my vertex is at 1, 0. Okay, and last but not least, again, working from left to right, I first see a vertical reflection in the x-axis. Then I see a shift. I'm going to put horizontal translation, I'm just abbreviating, left 3. And then I see a vertical translation, up 2. Okay. To get my key points, I'm going to first write the parent points. Okay, and I'm going to transform them. For the vertical reflection, I'm going to multiply the y values by negative 1. For horizontal translation left 3, I change my x values and I subtract 3 from them. Okay, and then vertical translation up 2, I'm going to add 2 onto my y values. Okay, and those would be my new points that I would graph. I would graph the negative 5, negative 2, the negative 4, 1, etc. Okay, and my vertex is this middle point here. My vertex is going to be the negative 3, 2, and I could have easily told you that just from looking at the expression up here, just because I can see that it's been shifted left 3, up 2. So there's my left 3 changes the x value and up 2 changes the y value.